7.3 applications of the dot product. The work is force dotted to force and displacement. Both are vector. So they dotted to each other, give you the work. Look at this question. A wheelchair is moved up a 200 hill with a constant force of 700 applied at an angle of 25 to the surface of the hill. Find the work done on a wheelchair. W is the force dotted to S. So it's the magnitude of the first vector multiplied by the second vector multiplied by the cosine of the angle between them, which is 25. That would be an example. So example, determine the angle between the two vectors. So you want to do the angle between two vectors. We know that the u dot v is magnitude of the u multiplied by magnitude of v cosine of the angle between them. We can rearrange for cosine theta. Also, you know u dot v, you can use the components to dot it. So u dot v is 4 multiplied by -2 plus 2 multiplied by 6. Magnitude of the u is the first x component power 2 plus the y component power 2 is square root, as you see that there. And the magnitude of v is -2 power 2 plus 6 power 2 square root of that Pythagorean theorem, basically. So using your calculator, simplify, you'll get this. You need to find it. Theta means theta is cosine inverse of the number that you get there. So here is the vector diagram. So as you know, the dot product is projection of the vector v on the u. If the angle is greater than 90 degrees, so the answer would be negative when you dot product. If the angle is 90 degrees, of course, the dot product between two vector is 0, or the projection of the v on u is 0, because this point you just perpendicularly come here, so there's going to be a point there. Projection of the vector v on u going to be 0 if the angle between two vectors is 90 degrees. So here is the projection vectors. If you want to project vector v on u, is magnitude of the u is magnitude of v multiplied by cosine theta. And so the direction of that will be along the u. Okay, make sure you understand what it means. So here is your v. Here is your u, right? So you want to find the projection of this one, the v on u. So that would be the projection. And make sure this vector, this projection of v on u, is along u. So the direction of the u is vector u divided by its magnitude. Basically, this is a unit vector. It's just the magnitude of that is 1, but the direction of that is in direction of the u. So this one is v multiplied by cosine theta, and then you multiply it by the unit vector u, because this is along vector u. So projection of the v on u, again, you can write it as the v dot u divided by u dot u multiplied by vector u. Because why vector u? Because this is along the u, and we divide by u power 2 means you're kind of canceling the magnitude of that. So projection of v on u, the magnitude of that is just v, magnitude of v multiplied by cosine angle between them, and if the angle is greater than 90 degrees, so of course you got a negative number, and if the angle is 90, you will get 0. So here is again the magnitude of the v on u is going to be v dot u divided by magnitude of the u. So look at this. We want to find the projection of u on v. Actually, this should be projection of v on u, because here is the v. Which one is the v? Okay, no worries. If this is u on v, of course, it's going to be magnitude of u multiplied by cosine theta. Knowing the magnitude of the u is 10 multiplied by the cosine of 25, right? And make sure this is the magnitude of the projection. So this would be 10, because it's going to be projection of the u on v. It's going to be u here, right? And it's going to be 10. The typo here. Now for this one, of course, I can use this formula. So v dot u I can do, so 5 multiplied by 11 plus negative 2 multiplied by 3. So that, and divided by magnitude of the v, right? So because this is the u on v. Here is the v on u. Make sure that's why u is there. Because u on v means it's going to be magnitude of the v. So it's 11 power 2 plus 3 power 2 square root. Put in your calculator, you get 4.3. So for the worksheet, you can do worksheet 4.3. You can try question number 1A, question number 2AB, question number 3AB, question number 4AB, question number 5AB, question number 6, question number 7, and question number 9.